Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing how to perform operations with polynomials. More specifically, I'm going to focus on adding, subtracting, and multiplying polynomials. As you can imagine, this is a topic that frequently appears on the ASVAB. That said, I realize that some of you are pretty good at math already, so in the description of this video, I also included timestamps, and those timestamps are associated not only with the topics that I'm discussing in today's video, but also with the practice questions in today's video. In total, there's 22 practice questions in today's video. So if you're good with polynomials, what you can do is you could just click on those timestamps, work out the practice problems, and move on. Otherwise, again, it's in your best interest to watch this video from start to finish. And moreover, you should pause the video whenever I get to a practice problem, attempt to work it out on your own, and then resume playing the video to check your solution. So all that being said, let's go ahead and get started with today's video. All right, so prior to performing any operations with polynomials, we do have to review one very important concept, notably the concept of like terms. And as you can see, I put the definition of like terms here to start, and it says like terms are variables that contain the same letter variables which are raised to the same exact power. So again, like terms are terms that contain the same letter variable which are raised to the same exact powers. So for example, let's take a look at two terms, notably 3a and 2a. Are those like terms? Well, they have the same letter variable. In 3a, our letter variable is a, and in 2a, our letter variable is a as well. Likewise, these are both raised to the first power. Therefore, they are like terms. And one thing you can do with like terms is you can add and subtract them. So 3a plus 2a would be 5a. So let's take a look at another example. Let's say we had 7y plus 10x squared. Are these like terms? Well, our letter variable in 7y is y, and our letter variable in 10x squared is x. Those letter variables are not the same, so these are not like terms, and therefore we could not add them. All right, let's look at one more example. Notably, let's say we had 7y squared plus 7y. All right, according to the definition of like terms, a like term has the same letter variable. So in 7y squared, our letter variable is y, and in 7y, our letter variable is also y. But that said, the second part of the definition says they have to be raised to the same exact powers. In 7y squared, our power is 2, whereas in 7y, our power is 1. In light of the fact that they have different powers, these are not like terms, and therefore we wouldn't be able to add them together. So with that in mind, let's go ahead and take a look at these 10 practice problems. Again, these are very simple problems just to get you comfortable with identifying like terms, and beyond that, adding or subtracting them very quickly. So if at this point you want to pause the video and work out these problems on your own, that's a good idea. Again, these problems are very, very simple. So this first one says 6x plus 2x. Again, according to the definition, a like term has the same letter variable as well as the same power. So in 6x, our letter variable is x, and in 2x, our letter variable is also x. Even though it's not expressed, you should know that these are raised to the first power, and in light of the fact that these have the same letter variables and are raised to the same exponents, we can add these together. 6x plus 2x is going to be 8x. And you may have noticed that it doesn't matter what comes in front of the letter variable. Those are called coefficients, and as you just saw, we're simply adding those together. All right, let's look at number 2 now. It says 5n minus 2. Again, according to the definition, for these to be like terms, they have to have the same letter variable, and they also have to be raised to the same power. So in 5n, our letter variable is n, and in 2, we have no letter variable. So in light of that, these are not like terms, and therefore we can't perform this operation of subtraction. So in other words, this one is as simplified as it's going to get. All right, so if we take a look at number 3, it says g plus 5g plus r. Let me just stress this, and I'm going to rewrite this over here so it's more clear. Whenever the coefficient's not expressed in front of a variable, it's implied that it's 1. So you can regard this as 1g plus 5g plus 1r. Again, typically that 1 is not expressed. As a matter of fact, when we simplify this one, we're going to get rid of it. So again, according to the definition, like terms have to have the same letter variable as well as the same power. So in 1g, we have the letter variable g, and it's raised to the first power. In 5g, we have the letter variable g, and it's raised to the first power. And here we have the letter variable r. So as we can see, like terms are 1g and 5g, and 1r is not a like term of those. So in light of that, we can add 1g and 5g together. 1g plus 5g is going to be 6g, and we'll just tack on this. And I'm going to drop this 1 because it's implied r. So g plus 5g plus r simplifies to 6g plus r. All right, let's take a look at number 4 now. It says 4x minus 3x plus 5. Again, according to the definition, for these to be like terms, they have to have the same letter variable as well as the same power. So we have our letter variable x raised to the first power. We have our letter variable x raised to the first power. So those two are like terms. Then we just have 5 with no letter variable. So it's not a like term. When we have like terms, we can perform the operation. So we could do 4x minus 3x, which will just leave us with 1x, or x, plus 5. All right, so that's that one. Pretty easy. Let's move on to number 5. We have 6z plus 8c plus 2c. Again, according to the definition, for these to be like terms, they have to have the same letter variable and be raised to the same power. So we have letter variable z here raised to the first power, letter variable c raised to the first power, letter variable c raised to the first power. So whereas 8c and 2c are like terms, 6c isn't. So again, when we have like terms, we can add and subtract those terms. So in this case, we can do 8c plus 2c, which is 10c, plus 6z. And again, we couldn't add 6c to 10c because it's not a like term. All right, let's keep working these out. We have 5w minus 3w minus 7. Again, according to the definition, they have to have the same letter variable as well as the same power in order to be like terms. And then if they are like terms, you can add and subtract them. Again, we have w here, first power here, whereas we have 7 here with no letter variable. So 5w and 3w are like terms. Therefore, we can perform this subtraction. 5w minus 3w is 2w, and then we'll just tack on that minus 7. All right, let's keep working these out. We have 6m plus n. So again, according to the definition, they have to have the same letter variable as well as the same exponent in order for us to add like terms. So here we have the letter variable m. It's raised to the first power. We have the letter variable m raised to the first power. We have the letter variable n. So 6m and m are like terms, n is not. So again, if it's not expressed, there's always an imaginary 1 there. So let's go ahead and rewrite this off to the side if we need to. This is 6m, and let me fix that real quick. 6m plus 1m plus n. 6m plus 1m is going to be 7m plus n. And we can't do anything else since 7m and n are not like terms. All right, number 8 says 6f plus 5f plus 8f Again, if they're like terms, we can perform that operation of addition. If they're not like terms, we can't. And according to the definition, like terms have the same letter variables raised to the same powers. So we have 6f here. Our letter variable is f. It's raised to the first power. That's implied. We have 5f raised to the first power. We have 8f raised to the first power. So clearly these are all like terms, so we can add them all together. So 6 plus 5f is going to be 11f. 11f plus 8f is going to be 19f. All right, so number 9 says 7p minus 4p plus 100. Again, clearly 7p and 4p are like terms, given that they have the same letter variable of p, and those letter variables are raised to the same power. So we can perform this operation of 7p minus 4p, but we can't do anything with this plus 100 because it's not a like term. So 7p minus 4p is going to be 3p plus 100. All right. And finally, number 10 says 4 minus 8y plus 2. We should be able to tell that 4 and 2 are like terms, whereas negative 8y is not a like term. So we'll perform 4 plus 2, which is going to be 6, minus 8y. And we're done with that one. So now that we've reviewed the definition of like terms, as well as worked out some very basic examples involving operations involving like terms, let's go ahead and start talking about polynomials. More specifically, let's review the definition of what a polynomial is. For some reason, a lot of people struggle with understanding what a polynomial is, but hopefully this definition makes it very simple and straightforward. So our definition here says, in mathematics, a polynomial is an algebraic expression consisting of variables and coefficients that involves only the operations of addition, subtraction, multiplication, and non-negative integer exponentiation of variables. Well, while it's easy to understand addition, subtraction, and multiplication, what does non-negative integer exponentiation of variables mean? It means that the power to which you raise the variable can't be negative. So if we have 4x squared, that is a polynomial. If you have 4x to the negative 2, that integer is negative. Therefore, this is not a polynomial. It's something else. Okay, so again, non-negative integer exponentiation, which I like the sound of, just means that the exponent has to be positive. So in all the examples you're going to see today, all the exponents are going to be positive. All right, that said, polynomials have different classifications. And let's take a look at that because I think a lot of people get these confused even though they're pretty simple. A polynomial that only has one term, such as 4x to the fourth, is what's referred to as a monomial. A polynomial with two terms, such as 4x to the fourth plus 7, again, this is one term, this is the second term, is what's called a binomial. A polynomial that has three terms, such as 4x to the fourth plus 7 minus 5az to the third. Again, here's our first term, second term, third term, is called a trinomial. And a polynomial that has four terms, such as 4x to the fourth plus 7 minus 5az to the third plus b. Again, here's our four terms. 1, 2, 3, 4 is called a quadrinomial. All right, so again, if you ever see these terms, monomial, binomial, trinomial, quadrinomial, again, that's just telling you how many terms there are in a polynomial. There's nothing more to it than that. All right, so with our knowledge of the definition of like terms, as well as our knowledge of polynomials in mind, let's go ahead and work on adding and subtracting polynomials. And as I stressed at the beginning of this video, this is very, very simple to do. So in order to add polynomials, you simply drop the parentheses and combine like terms. Well, that's pretty simple to do, so let's look at an example. So in this example, we have 2x squared plus 3x minus 7, all in parentheses, plus, in parentheses, 3x squared minus x minus 10. Again, to add polynomials, drop the parentheses, and then combine like terms. So let's go ahead and do that, and I'm going to do that up here. So the very first thing I'm going to do is drop these parentheses. We have 2x squared plus 3x minus 7 plus 3x squared minus x minus 10. Again, we just dropped those parentheses. Now we're looking for like terms that we can combine. Again, the definition of like terms is same letter variable raised to the same power. So if we look at our first term here, we can see that we have the letter variable x raised to the second power. If we look through all these other terms, do we have anything else that meets those two criteria? Well, this is x raised to the first power. This is just negative 7. But here we have x raised to the second power. So 3x squared and 2x squared are like terms, and therefore we can combine them. 2x squared plus 3x squared is 5x squared. And now that we've combined them, let's go ahead and just cross them out. That way this polynomial looks a little bit easier to work with. All right, so moving on to the next one, we have 3x. Again, our letter variable is x and it's raised to the first power. If we look through the rest of these terms, do we have anything else that's a like term? Well, this is just negative 7, but here we have x, and again, it's raised to the first power. So 3x and this negative x are like terms, therefore we can combine them. 3x minus x is just going to be 2x. And now that we've combined them, we can simply cross them out here to make this a little bit easier. And then finally, we have minus 7 and minus 10, which are like terms. Minus 7 minus 10 is minus 17. And just like that, we're done with this one. We took these two polynomials and we added them together. More specifically, we dropped the parentheses and then we just went through and combined the like terms. There's nothing more to it than that. All right, so as far as subtracting polynomials goes, it's very similar to adding polynomials. That said, we go about dealing with our parentheses as well as our subtraction sign in a different way. And if you're the type of person who likes instructions, here they are. It says when subtracting polynomials, drop the first set of parentheses, so that would be these here. Distribute the negative, so here's our negative, it's a subtraction symbol. We're going to distribute it here, here, and here. And at the same time, drop the second set of parentheses and then combine like terms. So let's go ahead and see what that looks like in practice. And it's not too difficult at all. Again, drop this first set of parentheses. So let's do that. We have x squared minus 12x plus 1. Take this negative and distribute it. So we're going to distribute it here, here, and then here. And at the same time that you're distributing this negative, go ahead and drop your second set of parentheses. So we have negative times 2x squared. A negative times a positive is a negative. And if it's helpful, you can imagine that there's a negative 1 here. And 1 times anything is just itself. So negative 1 times positive 2x squared is negative 2x squared. Negative 1 times positive 3x is negative 3x. And then negative 1 times negative 7 is going to be positive 7, given that a negative times a negative is a positive. Again, on my channel, I have a video in regard to how to multiply positives and negatives. So if that's something with which you struggle, go ahead and check out that video. But that said, let's go ahead and get back to this problem. Again, we dropped our first parentheses. we took our negative and distributed it. And at the same time, we dropped our second set of parentheses. So now all we have to do is combine like terms. Again, like terms, same letter variable to the same power. So if we look at x squared here, we're looking for something with the letter variable x raised to the second power, which is right here. So we have x squared minus 2x squared. That's going to be negative x squared. And again, if you can't add or subtract negatives, I'm going to create a video for that very soon. But basically, this is the same as negative 2 plus 1. Again, there's an imaginary 1 here. Negative 2 plus 1 is going to be negative 1. And the way you want to view this, if you can't understand this, is you break out your number line. Let's say here's negative 2, this is negative 1, this is 0, and this is 1. So we're starting at negative 2, which is right here. And on a number line, when you add, you go this way. When you subtract, you go this way. So this is negative 2 plus 1. So we're going to move to the right 1, which gets us to negative 1. And again, we don't express that 1 in front of our variable here, which is why it's dropped. So again, I'm going to make a video about this very shortly if you need help with adding and subtracting negatives. Just bear with me. I'm one guy making videos for the ASVAB, so it takes me a while to get around to covering everything. So with those two like terms combined, let's go ahead and move on. Now we have negative 12x as our next term. Again, this is letter variable x raised to the first power. So we're looking for another term with the letter variable x raised to the first power, which is right here. So negative 12x and negative 3x are like terms. Let's go ahead and combine them. Negative 12x minus 3x is negative 12x, negative 13x, negative 14x, negative 15x. And let's cross them out now that we've combined them. And then finally, we have 1 plus 7, which is just 8. All right, so that's all there is to subtracting polynomials. Again, drop the first set of parentheses, distribute the negative, at the same time drop the second set of parentheses, and then combine your like terms. All right, so that's that one. Let's go ahead and move on now. All right, so we've reached the first point in this video where I would recommend that you attempt to work out the practice problems on your own. There's going to be 10 of them here, and none of them are too difficult. So if you'd like, go ahead and pause the video, work out these questions on your own, and then resume playing the video to check your solution. Initially, I'm going to work these out very slowly. But once we get to about question 6, I'm going to start moving very quickly because, again, the goal is to give you enough practice in this video such that you're able to do these problems very quickly as well as very accurately. I know I'm saying like terms, same letter variable raised to the same power. Hopefully that becomes second nature to you where you can decide if something is a like term with something else or not almost instantly. So with that in mind, let's get through these practice problems here. All right, so this first question says 7j to the third minus 2 plus j to the third minus j minus 3. In case it's helpful, you can say that we're adding a binomial to a trinomial. Again, a binomial is a 2-term polynomial, and a trinomial is a 3-term polynomial. But that said, our first step here is going to be to drop the parentheses, so this becomes 7j to the third minus 2 plus j to the third minus j minus 3. All right, let's combine like terms now. Our first term here is 7j to the third. If we're looking for its like term, we're looking for a term that has the same letter variable j raised to the same power of 3. And if we look through our other terms, we can see its like terms right here. Again, we have the same letter variable j raised to the same power 3. If it's helpful, you can place a 1 here, and now we can combine them. 7j to the third plus 1j to the third is going to be 8j to the third. And now that we've combined them, we can go ahead and cross them out. Let me stress this. order is important when you're simplifying these polynomials. And the way you want to order them is like this. You want the term with the highest exponent first. After that, you want the term that has just a letter variable. And then at the very end, you can put your whole numbers. So in this case, we can see that next we have the whole number -2. But that said, we still have this letter variable j. This j is always going to come before a whole number. So let's work with it next. And again, we have the letter variable j raised to the first power. If we look through the rest of our terms, we can see that none of them are like terms. So we're just going to bring it down accordingly. And now we can cross it out. And then finally, we have -2 and -3, which is -5. All right, so that's the first one. Nothing too difficult there. Let's go ahead and move on to the next one. Again, we have a binomial that is a 2-term polynomial plus a trinomial that is a 3-term polynomial. So let's go ahead and drop these parentheses and combine our like terms. So we have 8a to the 5th minus 4 plus 3a to the 5th plus a minus 2. Let's start combining our like terms. Again, we're going to start right here with 8a to the 5th. Again, we're looking for another like term, which means we're looking for another term that has the variable a raised to the 5th. And if we look, we can see that the only other one is right here, a to the 5th. And so we're going to combine 8a to the 5th with 3a to the 5th to make that 8, 9, 10, 11a to the 5th. And now that we've combined those, we can cross them out. As we saw previously, order does matter. So instead of working on these whole numbers next, I'm going to move on and work on our letter variable a here. And if we look through the rest of the terms, we can see there are no like terms with just a. So we'll go ahead and drop that down accordingly and cross it out. And then finally, we have -4 and -2. And that's going to be -6. All right, so that's number 2. Nothing too difficult there. Let me put my box around it to indicate that we're done with it. All right, number 3 says 6m squared plus 1 plus 2m squared plus 9m minus 1. Again, we have a binomial and a trinomial, and we're adding those. So let's drop the parentheses. We have 6m squared plus 1 plus 2m squared plus 9m minus 1. Now that we've dropped parentheses, let's start combining like terms. Let's start right here. We have 6m squared, so we're looking for another term that has m raised to the second power. We can see that's right there, so let's combine 6m squared and 2m squared to be 8m squared. And now that we've combined them, let's cross them out. Again, a letter variable is going to come before a whole number. So we're going to jump right here to this 9m. We don't see any like terms with 9m, so we'll just go ahead and bring it down accordingly. Cross it out. And then we have +1 minus 1, which is just 0. And we don't have to write +0 here. So we're done with this one. Number 4 says 3m squared plus 1 plus m squared plus 3m minus 2. Again, we're just adding these, so drop the parentheses, 3m squared plus 1 plus m squared plus 3m minus 2. Combine like terms now, so if we start right here, we can see that we have the letter variable m raised to the second power, and we can see that we have its like term right here. Again, letter variable m raised to the same power. And if it's helpful, you can imagine there's a 1 there. So 3m squared plus 1m squared would be 4m squared. We'll cross that out there. And then we have 3m and whole numbers left. So this 3m is going to come next. There's no other like term with it. So we'll go ahead and just bring it down. This will cross out here. And then we have 1 minus 2, which is -1. And we are done with that one now. All right, so let's go ahead and work on this one now. Again, we're just adding a trinomial that is a 3-term polynomial with another trinomial that is a 3-term polynomial. So let's just drop those parentheses and combine like terms. So we have negative 5x squared minus x plus 4 minus 3x squared minus 5x plus 2. Let's start right here with combining like terms. Again, this is negative 5x squared. So we're looking for a like term of x squared, has to have the same letter variable x raised to the same power of 2. We can see that's right here. That's negative 3x squared. So we can combine those two. Negative 5x squared and negative 3x squared is negative 8x squared. Now that we've combined them, we can cross them out to make this a little bit easier to look at. Next, we have the letter variable x raised to the first power. And we can see that its like term is right here. We have negative x and negative 5x. If we combine those, that becomes negative 6x. And now we can cross them out. And then we have 4 and 2, which is just 6. All right, let's go ahead and move on to number 6 now. And again, now we have the subtraction. I don't know why my pen marked that. Now we have the subtraction of trinomials. We have this trinomial minus this trinomial. So again, if you recall, the first step is to drop the first set of parentheses. So this becomes negative x squared plus x minus 4. After that, we're going to take this negative and distribute it here, here, and here. And at the same time, that's going to enable us to drop our parentheses. So again, you can imagine there's a negative 1 here if that's helpful, but negative times 3x squared is negative 3x squared. Again, a positive times a negative is a negative. Then we have negative times negative 8x. A negative times a negative is going to be positive. So this becomes plus 8x. And then finally, we have negative times negative 2. Negative times a negative is a positive. All right, now that we've gotten rid of our first set of parentheses, distributed this negative, and dropped our second set of parentheses at the same time, all we have to do is combine like terms. Our first term here is negative x squared. So we're looking for x raised to the second power, which is right here. So negative x squared minus 3x squared is negative 4x squared. Let's cross those out now that we've combined them. Our next term is right here. It's x, and this is technically x raised to the first power. So we're looking for its like term, which is right here. This is 8x. X and 8x, again, if it's helpful, put that 1 there. 8x and x is going to be plus 9x. Go ahead and cross that out. And then finally, we have negative 4 plus 2. Negative 4 plus 2 is negative 2. All right, so I've noticed that in some of my videos where I work out negatives plus positives, people struggle to do that mentally. So pretty soon, I'm going to create a video in regard to adding and subtracting positive numbers. But in short, it's actually very easy to do if you visualize these numbers on a number line. So here we had negative 4 plus 2, and let's go ahead and make a nice little number line here, and let's make a better number line than that if we would. And again, we're going to start at negative 4, negative 3, negative 2, negative 1, 0. All right, so on a number line, when you move to the right, that means you're adding. When you move to the left, that means you're subtracting. So let's start at negative 4, which is right here, and then we're adding positive, or we're adding 2, which means we're going to go to the right 2 places, 1, 2. And that's how we get to negative 2. Okay, again, I'm going to make a video on that very shortly, but I just wanted to mention that in case you got lost doing that mental math there. All right, so number 7 says 8x squared minus 3x minus 5x minus 5 minus 8x squared. As you can see, we're taking this binomial and subtracting it by a trinomial. And so if you may recall, our first step is to drop our first set of parentheses such that this just becomes 8x squared minus 3x. Now we're going to take this negative and distribute it here, here, and finally here. Negative times positive is going to be negative, so negative times positive 5x is going to be negative 5x. Negative times a negative is going to be a positive, so negative times negative 5 is just going to be positive 5. And then finally, a negative times a negative is going to be positive, so negative times negative 8x is going to be plus 8x squared. Let's start combining like terms now. Let's start over here. Again, we can see that we have 8x squared. Our letter variable is x. It's raised to the second power. So if we look through all these other terms, we're looking for x raised to the second power, which we can see is over here. So we can combine 8x squared and 8x squared. That's going to be 16x squared. And we can cross these out now that we've taken care of them. Next, we have negative 3x. Again, that's x raised to the first power. So any other like terms is going to be x raised to the first power, and we can see that's right here. So let's combine those two. Negative 3x minus 5x is negative 8x. And then finally, we just have 5. All right, so that's that one. Nothing too difficult there. All right, so now we have a trinomial minus a trinomial. Again, if you recall, the first step is to drop our first set of parentheses. So this is going to be negative x squared minus 5x minus 3. Then we're going to take this negative and distribute it here, here, and here. And at the same time we do that, we're going to drop our parentheses. So negative times negative 7x squared just becomes positive 7x squared. Again, a negative times a negative is a positive. Then we have negative times negative 8x, and negative times a negative is a positive, so this is positive 8x. And then finally, we have a negative times a negative, so negative times negative 8 is plus 8. All right, now that we've distributed that negative and dropped our second set of parentheses, we can go ahead and combine like terms. So we have negative x squared and 7x squared. Those combine to be 6x squared. So we'll cross those out now that we've combined them. Then we have negative 5x and 8x. 8x minus 5x is simply going to be plus 3x. So we'll cross those out. And then finally, we have negative 3 and positive 8. 8 minus 3 is, of course, 5. And there we have it. All right, 2 more to go. All right, so we're subtracting a binomial by a trinomial in this case. So let's drop our first set of parentheses. This becomes negative 2x to the third plus x. Let's take our negative and distribute it here, here, and here. So we have negative times positive 7x. That's going to be negative 7x. We have negative times negative 3, and negative times a negative is a positive. So this becomes plus 3. And then finally, we have negative times a negative. So negative times negative 7x to the third becomes positive 7x to the third. Now that we've distributed that negative and dropped our second set of parentheses, let's go ahead and start combining some like terms here. So we have negative 2x to the third there and 7x to the third there. Let's combine them to be 5x to the third. We can cross these out. All right, our next set of like terms is right here. Positive x and negative 7x. Positive x and negative 7x is negative 6x. So we'll go ahead and cross those out now that we've taken care of them. And then we just have this plus 3 hanging out here. So we'll go ahead and tack that on at the end. And we are done with that one. All right, so our last problem is a little more challenging insofar as we're taking a trinomial and we're subtracting it by a quadrinomial, that is a 4-term polynomial. So process is the same. Drop the first set of parentheses. This becomes x to the third plus 3x squared plus 5. Take our negative and distribute it accordingly. So we're going to distribute it here, 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 and here. And at the same time that we're distributing that negative, we're going to be able to drop our second set of parentheses. So this becomes negative times positive 7x to the third, which is going to be negative 7x to the third. Negative times a negative is going to be a positive, so this is plus 9x squared. Negative times a positive is going to be a negative, so this is minus 8x. And then a negative times a negative is a positive, so this is plus 5. Let's go ahead and carefully combine our like terms here. So we have x to the third and x to the third here. Specifically, we have 1x to the third. You can put that 1 there if you need it. 1x to the third. We have 1x to the third minus 7x to the third. So that's going to be negative 6x to the third. Cross those out now that we've taken care of them. Next, we have 3x squared, and we can see that we have 9x squared. So let's go ahead and combine those next. 9, 10, 11, 12. So this is plus 12x squared. Let's cross those out now. And then before we deal with these whole numbers, we have this variable of just x to the first to deal with. So let's bring that down here so that our polynomial is in order at the end. So we have negative 8x. This crosses out. And then finally, we have 5 plus 5, which is 10. And we can cross those out. So as we can see, when we subtract this trinomial by this quadrinomial, the result is this. So since this video is getting a little long, I've decided to break down this topic into 2 videos. Again, in this video, I covered how to add and subtract polynomials. In a video that I'm going to upload tomorrow, I'll go through the ins and outs of multiplying polynomials. And if you watch 2 of those videos together, you'll have a complete understanding of everything you need to know about polynomials for the ASVAB. As always, you're more than welcome to leave feedback in the comment section below. In addition, if you find my content helpful, please consider subscribing to my channel. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.